Many consumers are still unfamiliar with the term Internet of Things. Although computer scientists have been discussing the concept for decades, the term wasn't used until Kevin Ashton coined it in 1999. Despite its potential, early projects were stymied by a lack of sophisticated technology and consumer demand. But as the technology has improved and became more affordable, the term has come to life in many different applications. The IOT process involves connected personal devices and data transmission, which can take place wirelessly or over a wired network. The information can then be analyzed by a central computer or cloud. The data may also be transferred in phases, with some devices aggregating, formatting, filtering, and transmitting important data to other devices. The first layer of the IoT network includes physical sensors and actuators. These sensors and actuators receive commands and route them to the next layer. The perception layer may query weight, position, motion, or vibration. The perception layer is typically connected to a dynamic host configuration protocol (DHCP) server. This server is responsible for determining which IoT objects can function over a network. Typically, IoT devices can be configured through a software application, but some are self-controlled and have built-in web servers. With increased access to data, companies are able to optimize their processes. This data enables business process management teams to evaluate their processes and identify any inefficiencies. Further, IoT provides a more complete picture of individual customers and audiences. IoT can be an essential tool for enhancing employee productivity. As more IoT applications emerge, the average home is already experiencing the benefits of this technology. These applications range from simple location tags for keychains to smart fridges that tell you when to buy a certain item. According to IoT Analytics, there will be 12.3 billion connected devices worldwide by September 2021 and nearly 27 billion by 2025. The IoT brings many benefits, but it also presents new challenges. One of the biggest is security. Many of these connected devices are inherently vulnerable to hacking. Devices connect to each other to share information. This means that a single vulnerability in one device can allow a hacker to manipulate data and access sensitive information. This makes it crucial that manufacturers update their devices regularly. This is especially important for connected consumer products, because many of these devices ask for personal information, and hackers could potentially sell it to a third party. Some IoT devices are vulnerable to botnet attacks. Another challenge is that most of them lack storage and processing capabilities and encryption capabilities. This can expose sensitive data and make it easy for hackers to manipulate security protocols. With the development of smart appliances, the Internet of Things is expected to provide valuable data and analytics. It will also make it easier for people to control multiple devices through one interface. The Internet of Things also helps people to stay connected when they're on the move. With the help of smart devices, you can monitor the health and performance of your home, including sensors and energy use. Connected IoT devices need a lot of computing power to function. They need to process data in order to make informed decisions. Edge computing technologies will help them process data locally instead of in the cloud. The underlying technology for IoT devices consists of microcontrollers. These devices provide computing power, memory, and connectivity to the internet. They also have embedded sensors, which act as digital eyes and ears. Microcontrollers are inexpensive and have low power requirements. This makes them suitable for a wide variety of IoT devices. Smart objects in the Internet of Things, IoT, process information they receive using an algorithm pre-programmed into the object. They often interact with other elements of the IoT infrastructure, including networks and sensors. IoT platforms will also interface with big data analysis tools to make sense of the large volumes of data collected by smart objects. These objects also have the ability to act autonomously and respond to alarms or other conditions. A smart object transforms a physical world into an online world that can communicate with humans and other smart smart objects. A smart object contains a processor, sensors, and software program that enables it to sense its environment, interact with humans, and exchange information. Initially, research on smart objects has focused on the technical aspects and application scenarios. However, today, smart objects are also being used in a wide range of industries, from supply chain management to industrial workplace support. IoT smart buildings utilize sensors to track the energy and temperature of a building. This data can be used by facility managers to reduce energy usage and reduce utility costs. They can also be used to identify problems before they occur. The technology is typically divided into 3 layers, each performing a specific task. These layers are called data sensing, data processing, and data reproduction. For example, an IoT smart building platform may measure temperature and humidity and store this information in a dedicated big data cloud. Smart buildings may also incorporate apps that allow tenants to submit feedback, track their carbon footprint, and contact building management. They may even be able to reserve a room, view available parking spots, or receive notifications if there are problems. Buildings equipped with IoT technology can benefit the hospitality, travel, and real estate industries, and will be more common in the next few years. IoT and smart homes have the potential to change the way we live. They can allow you to control and optimize every aspect of your home, from basic appliances to luxury consumer durables. These devices are becoming increasingly convenient and easy to use. They will eventually become a standard part of new products, and people will be quickly accustomed to using them. One of the biggest challenges in the adoption of IoT and smart homes is the cost of the devices themselves. Moreover, privacy concerns are a major concern. Also, current technological limitations make it difficult to connect multiple IoT devices to form a seamless network. The IoT and smart cities concept has several benefits, but the implementation of these technologies is not without its challenges. The most significant barrier is the lack of funding. These technologies require a large amount of capital equipment and overhead to be implemented. Therefore, they need a solid strategy and execution to be successful. One way to overcome these issues is through public-private partnerships. This kind of collaboration can help define the requirements and fund the implementation of smart cities. Applications for IoT can be found in a variety of industries. One example is agriculture, which uses sensors to determine soil properties and determine which crops are most suitable. They can also help gather data about short-term weather and climate. The IoT can connect almost any object to the internet and share its information with the outside world. For example, a smartwatch could detect a user's sleep cycle and send a signal to turn on a geyser or shower. It could also be used in cars to send alert messages about the level of fuel in the tank. Another area that could use applications for IoT is asset management. This type of technology allows businesses to log information about their assets, track their status, and prevent any unexpected problems. It can also help with predictive maintenance.